Welcome to Lab 2 GIS Overlay Analysis. Today we're going to be going through and doing several different types of overlays and answering several questions that then you will go on to bblearn and provide answers for in your lab questions. To start out with, we're going to open a new ArcMap project which I have here, and we're going to make sure that our data from Lab 2 is downloaded. I've downloaded that, so you'll need to get that from bblearn. Unzip it and save it into your class folder. So mine is 407 and lesson 2, and this will be lab 2 data, and it's in a folder called Cellway. To begin, we have a list of data layers to add. So I'm going to navigate to my class folder and add the layers indicated, starting with SBWPVT right here, and you can use your control button to select multiple ones. So we've got an elevation file, fire starts 1986 to 1992, HUC 5, which is a hydrologic unit layer, fires in 2000 right here, Idaho state boundary, and a pvt.dbf file right here. And we'll click add. We have unknown spatial reference, that's just fine. We'll define that in a little bit. Okay, so here we are. To start with, we don't need all these layers on. So you have these different options, list by source or list by drawing order. I like to list it by drawing order usually. The reason it goes to list by source is that we have this DBF file in there, and that's where that's available. So you can see that it's available there, but not available in the list by drawing order. Can go back and forth when needed. So now that we've added those layers, we first need to turn on our Spatial Analyst toolbar in order for us to start working with these. We're going to add the Spatial Analyst extension for working with raster data. So in the top menu, select Customize and then Extensions. And you're going to make sure that Spatial Analyst is checked. It might not be, so check that box there and press close. And then to display the toolbar, we'll need to go to Customize, Toolbars, and make sure that Spatial Analyst is checked down here. And that'll make the Spatial Analyst toolbar available. And you can slide it up to incorporate it with your toolbar. I'm going to close my layout one. To standardize your output locations, your cell size, your area that you'll be processing in, then you can go to Geoprocessing and Environments. This makes it a lot easier for you to create your output, know that it's being saved to the right location at the right cell size and with the right features that you'd like, as opposed to changing them every time. So we're going to go under Workspace, and we're going to pick our default folder that these the things that we'll be creating get saved to. So I'm going to pick a location, and I'm going to put it in the lab or the lesson 2 folder. And then Scratch Workspace, I'm going to make the same. Just copy and paste that in. And under raster analysis, we're going to make sure that we have the proper cell size specified. And the easiest way to do that is to select a layer that you have that you'll be working with, and then it'll auto-populate with the proper cell size. The mask here is what you would select if you had a very large grid that you'll be working with, and then you are only interested in producing output for a certain area, this is a great way to select a fire perimeter if you're doing analysis on vegetation type or on post-burn severity. For now, we'll just have the SBW PVT as our mask, and later you can go back and change that if we're doing different kinds of analysis, but this is a really great tool to save time in clipping the layers that you produce. So I'm going to explore my data a little bit. I'm going to check off Idaho. We included the Idaho one there just so you could have some reference for where we were. And I'm going to zoom in. One feature that I'd like to point out now that we'll also discuss in the base layers discussion is the opportunity to add base maps. You could press the down arrow here next to plus and add a base map. So if you wanted to see a little bit more about where the imagery was from, you could select imagery or any of these other options. You can play around with those. They are quite large, so they might take a little bit of time to load, but it will give you an extra view of what you're looking at. So let's zoom out a little bit. So you can see roughly the type of cover that we're working in and where we are, what kind of geographic features are around us, which is useful. So at this point, it's going to be important for you to save your ArcMap project. One thing that you'll notice when you start working with Spatial Analyst or any of the other toolbars, you increase your likelihood of Arc shutting down unexpectedly, and you'll lose the work that you had done, or it'll be hard to find the place where you were. So I'm going to save as, and I will save in my lesson 2 folder and call this lab 2 overlay. The first task that we're going to do is we're going to join the potential vegetation type to the potential vegetation type grid. The reason for this is, let's first look at our potential vegetation type grid and see what it looks like. So celery bitterroot potential vegetation type. Let's open this attribute table, and pretty uninformative. So we know that we have some values, we know that we have a number of cells that contain those values, but we don't know what those values mean. So what can we do to improve that? Well, let's look at our potential vegetation type lookup table, which is here. Open that, and you can see you have a potential vegetation type code and associated with a name. So it would be much preferred for our celery bitterroot potential vegetation type to have that name associated with it as well. So the first thing we'll do is we will right click on the celery bitterroot PVT data, and we're going to select join and relates and select join. So then we're going to enter values. Here we're going to put value. So it's saying look to this column in the SBW PVT file, and in the PVT file we're going to be joining that with the PVT code. So it's saying that this is the value, that this is the name of the column that's going to be the same in both of those files, and this is the one that needs to be added to the SBW PVT file. And then we'll click OK. And now we will open our attribute table and see what's changed. So you can see that we have a lot of additional columns now with some different names, but what we're looking for is, do we have our values and do we have the names of the PVTs associated with them? And we do. And close that. Now we'd like to display our potential vegetation type area so that we can see what that looks like across the image. So I'm going to remove some of these layers or turn them off for now and just get a good look at what we're currently working with. So I'm going to right click, zoom to layer. So right now we have some color schemes that don't make a lot of sense in terms of what they represent on the ground. And so right clicking, going to properties, and selecting in symbology, selecting unique values, And for value field, under the PVT name, we're going to pick some better colors. You may need to add all values if they don't automatically populate. And you could go in and individually select the colors that you'd like for each of these, but I find that usually there's a decent match in the different color schemes. This one does seem to represent vegetation well, so maybe try a couple out and see if they do a good job. So the main thing is that blue needs to always represent water. If it's anything else, it gets confusing. So this looks decent to me. I'm going to press OK. And now I can see a better representation of what those potential vegetation types are on the ground. So now if you were to close this ARC project, or if it were to close unexpectedly, and then you were to re-add these layers, you would have to go through that same process again. One way to save that step would be to right-click on the layer that you've been working in and save as a layer file. So if I navigate to the folder that I'm working in, and this would be saved as the sbwpvt.layer, and I would save that. Then in the future, if I opened up a blank ARC map, and then I could add that. It's not a part of this exercise, just something useful for the future. In this and other exercises, we will be doing quite a lot of changing to individual layers, so you might want to save those changes. Let's just test that out. Let's see what that layer looks like when we add it. So if we were to add the layer we just created, would look like this. Add. It's acceptable for now. As you can see, it's in the same settings. And if we opened the attribute table, it would have the same attribute table. Let's add the original file. So as you can see, it's got a lot of different colors haven't been adjusted, and the attribute table has not been altered. So we have to do that work again. In this next step, we'll be answering some of the questions that are included in your lab questions. So make sure to have your lab notebook out, take notes on what the answers are, and then when you get to the lab questions, you can simply insert those numbers in there. So the thing that we're going to be the first question we'll answer is how many fires started in the Selway Bitter Wilderness in the time period between 1986 and 1992. We want to know what the fire occurrence rates are. The first thing I want to do is clean up my table of contents. I'm going to press the control button, and I'm going to press this minus key. It closes everything or minimizes everything. I'm going to go back to my table view, minimize that, and then I'm going to turn everything off and just turn on my fire starts. I'm going to right click on this layer and open the attribute table. And I'm going to locate the total number of fire starts, which in this case, each row is one fire start. And so the number of rows will indicate the number of fire starts in that time period. And as you can see here, this is a total, so 641 fire starts there. Second question is, how many of those fires have a final size larger than 1,000 acres? So in this attributes table, we're going to click the table options, which is up here in the upper left corner, and we're going to select by attributes. First, we're going to double click on fire size, final size. This is a column in the table, so it's saying look in the final size column and find any of those fires that are greater than 1,000 acres. And when you are working in any kind of dialog box like this in ARC, it's best to use the options included in the dialog box as much as possible. So don't type in the greater than symbol from your keypad. Try and press it there, and then I will type in 1,000. And then click apply. So now you can see how many fires were selected out of those 641 that are larger than 1,000 acres. For the next several questions, you'll need to be making a summary table to compile the information. The question is, what are the causes of fire starts in the Selway Bitterroot Wilderness between 1986 and 1992? And so we'll keep this attribute table open and right-click on the heading for the fire cause column. Let's locate that. And ARC includes a tool for summarizing column information. And we're going to expand the option down here for final size. So these are the where you select the outputs that you'd like to see. And since our question is about the total number of fire starts for the Selway Bitterroot, we're looking for a sum. So we'll want the sum of those fire starts. We'll click, make sure that it's going to the right place here. That's acceptable. Might change that name to fire cause summary. And then click OK. And I do want to add the table to the map. I'm going to close this dialog box and take a look. Notice it's under one of these folder options here, so fire cause summary. I'm going to right click and open this table. So now I can see that I've got a fire cause, the number of fires that fell under the classification of that cause, and then the sum of the fire size for those causes. With this information, you can answer the question in question 3. Now we can see that there were 2 different types of fire causes, and the number of fires that fell into each of those fire cause classifications, and how many acres those fires resulted in. In order to understand what the cause of those fires were, other than just a number, you can refer to your lab, and there's a list of the numbers associated with those. This list comes from the metadata, which is associated with this file. And metadata is background information that provides additional information when those layers were created, or like in this case, extra information on what those numbers might mean. Let's take a second to look at the metadata file. When opening this up outside of the ARC environment, you can see all the additional base layers, and so it is a little bit harder to find things. Let's go to the fire start file. So we're looking for the .dat file, and in order to open a file like this, we'll need to right-click on it and select Open With, and I'm going to find additional apps to open it. I'm looking for either Notepad or WordPad, some kind of basic Word document. And in this file, we have the creator of the information, when it was created, lots of background information, and then the descriptions for fire starts. So all of this information we'll work with a little bit more in the future, but this is a great way to find out where the files that you're working with were created. And as far as passing information off when you're working as a GIS specialist, those metadata files become very important to save what was done to those images. So back to our ArcMap project. The next 2 questions, question 4A and 4B, you can answer using similar techniques. And again, going back to your main attribute table here for fire starts, and using the summarize table and making different selections. So go ahead and do those ones on your own. Next, we're going to be moving on to point to polygon. And this is a spatial join, and it's different from the joins that we had done previously. Instead of adding a field to a table or a column to a table, we'll actually be creating a new output layer, since these are going to be pulling information from two different layers and making an additional feature. So the answers to this question involve an overlay analysis or spatial join between our HUC5 layer, or a fifth order watershed, and the point layer of fire starts. So we're going to go to my drawing order here, and I'm going to turn on my HUC5 layer and my fire starts. And the first thing that I'd like to do is join a portion of these layers. So I'm going to right click on my fire starts and select join, joins and relates, and join. And under the question of what do you want to join in this layer, we're going to select join from another spatial location, which gives us some different features here. So it auto-populates with HUC5 since that's the first one on the list. And we're going to name the output layer and store it in the appropriate folder. Now, notice that as I've been doing this, that these have been saved to the folder that I have intended. That's because when I set up that those initial options for Spatial Analyst, the geoprocessing options, that has saved me the step of having to redefine where I want to save each of these outputs. But I would like to change the name, and I'm going to change the name to Fire Locations HUC. And press OK. So our output's been added, and it's a point layer, and I'm going to open that attribute table, and I'm going to use the summarizing that we had done previously to summarize the number of fires in each watershed. For this attribute table, first sub is the attribute name that contains the name of the watersheds, which will be what we refer to. So this is first sub. So unlike the previous part of this exercise, you won't need to select something like finalize, since we're going to be just looking for the numbers of fires that occurred within each watershed. So since this is the different names of the watershed, I'm going to right click here and click summarize, and just make sure that that's the proper location, which it is, and rename this to something meaningful like number of fires HUC5, and we'll add that to the table, and then we will open that attribute table, and we have a handy dandy summary of the name of the different watersheds and how many first sub, or how many fire starts, there were in each of those watersheds. Now remember again that ARC will periodically crash, so I'm going to take this moment to save my work. In the next step, we're going to derive slope and aspect from your elevation layer. So in ARC10, raster tools are located in the Spatial Analyst Tools toolbox in the ARC toolbox, which is located up here somewhere. It might be different for your computer. It's a red toolbox. Click on that to open it, and it might open freestanding. You have a couple different options of where you can place these. You can double click on the top and it'll bring it to the side and cover up your table of contents and turn that into a tab. You can also make this small. You can auto hide it, and then to remove that, you can pin that again, and you can close this out here. Now if you accidentally close your table of contents, which has occasionally happened to me, and it's taken me a while to find it again, it's just up here next to the ARC toolbox. So table of contents, and I'm going to open my ARC toolbox, and I'm going to go to under Spatial Analyst Tools, Surface, and Slope. Double click. For my input raster, I'll select elevation, and this is an acceptable location for my output raster. And I'm going to keep this in degrees and the z factor of 1, and I'm going to press OK. Now, while ARC is calculating, sometimes I get a little bar down here that helps me know that it's processing it. Sometimes I don't seem to get that. Another way you can check to see how things are progressing is you can go to geoprocessing and go to results. And now you can see that I've got a little timer here. These are some previous slopes that I've calculated, and one of them threw an exception after about 2 minutes, and then I reran it again, and this second one took about 20 minutes to run, but ran eventually. And then this one here looks like it completed just fine. So if you do have some problems, just try running it again and see if you get any kind of different result. So it's completed. You saw a little message pop up in the bottom right corner. Close this out. And now we'll do the same thing for aspect. Input raster is elevation, and then notice it's labeled aspect SPW. We'll keep that the same. Click OK. And we're processing aspect, and I'll just check my geoprocessing here. Looks like it's working on that. So now we have our slope and aspect layers have been added. I'm going to close my ARC toolbox and look at what's been created. So here's our aspect, and here's our slope. And we'll use these slope and aspect grids later in the lesson. The next step we'll be taking is an overlay analysis with point to grid, and you'll be using what we do here to answer questions 6 and 7. So we're going to be looking into how many fires started in each potential vegetation type, and if the fire starts were random, and the number of fires in each of the PVT that would be proportional to the area occupied by that PVT. So in order to determine if the fire starts are random, you'll need to calculate both how much area is in each PVT and the number of fires in each of those PVTs. So the first thing we need to do is to calculate the area, in this case from a grid. So we're going to right-click on the layer that we are curious about and open its attribute table. Minimize these for now. Turn off slope. So first I'm going to clean up my table of contents a little bit. I have a couple of extra files here that I was using to demonstrate. So now we'd like to calculate area for each of the potential vegetation types for our file. So our file of choice is the SPW PVT. The first thing we need to do is to add a column for acres for calculating. Go here and add a field. We're going to call this acres. And because the numbers that we'll be calculating are quite long, we'll select the long integer and we'll select OK. So it adds our column here for acres. And now we're going to be using raster calculators to make a calculation here. Now this is something that occasionally I have error messages that pop up. And so if we do, then I'll show you a workaround. And if you are able to do this without that workaround, then that's great. So go into field calculator. And it says we're going to be making some edits outside of an edit session, which is fine. And so we'll be selecting our count column here. Now for count, it is the number of pixels that are in that potential vegetation type. Since they're 30 by 30 meters, they have a known area. So what we need to do is think about how many acres each one of those pixels are. And so the first thing we have to understand is that a 30 by 30 meter pixel is 900 square meters, and we have to find the equivalent of that for acres. So we know that there are 4,047 square meters in an acre, which we can then understand that if we divide 900, so 900 square meters per pixel divided by 4,047 square meters in an acre, then we get 0.222 acres in a pixel. So if you need to pause the presentation and think about that for a little bit, go ahead. I'm going to say times 0.222. And that's going to give me my number of acres per potential vegetation type. And then I click OK. So now I get an error message here. There was a failure during processing. Check the geoprocessing results window. So I'll check that and see what the error was. And it looks like I have this error message here. So I actually already went ahead and searched on the internet and tried to find some other solutions that could fix this, and I was unable to find solutions. So the next best thing you do in ARC when you come across a problem is you think about other ways that you can try things. So I decided that I would try doing the same calculation with the layer before it had been joined. So I'm actually going to re-add my original SBW PVT, add that, and notice in my attributes table it's not joined and my colors aren't set up right, but really my main objective is to figure out the acres per potential vegetation type. And so what I'm going to do is add my column now. Acres, again, make it long integer, select OK, and field calculator, yes, and select count times 0.222, click OK. So now we have our acres calculated without any errors. Maybe someday I'll figure out what that error means. Today might not be the day for that though. So the next thing I'd like to add is a column for hectares, since that's what your questions are asking. It's good to have both acres and hectares. They're used for different reasons. So again, we're going to go here, add field, and select or type in hectares. And again, select long integer and OK. And with hectares, again, we're thinking back about that calculation. We know that there are 900 square meters in a pixel. We also know that there are 10,000 square meters in a hectare. So therefore 900 divided by 10,000 equals 0.09 hectares in a square or in a pixel. So go to field calculator, and it remembers the previous calculation that was done, so we'll delete that and press 09 and click OK. So now we have our hectares generated, and now I still do want to have the name of my potential vegetation type associated with this information so that I can answer my questions. And so I'm going to close this, and I'm going to follow the procedure that we described in the first step of joining. So I'm going to join my value field to my PVT code, click OK. And now I can see which potential vegetation type has this acres and these hectares. As you'll notice in the directions, there are some directions for doing the same thing with polygons, which can be really useful when you're trying to calculate area for multiple fire progression days or other various areas, let's say for hydrologic units. So this can be easily applied to similar process can be applied to polygons. So now that we've created a new SBW PVT, I'm going to go ahead and take a second just to reformat that so that it looks how the original one looked. Properties, symbology, using the name, and color ramp, and OK. Just to avoid confusion, I will remove the old one. All right. So in this next step, we're going to be relating points to grids, similar to the idea of step 6, but instead of relating points to polygons, we'll be doing it to grids. So again, in these spatial analyst tools, under extraction, we're going to select extract values to points. Select my fire starts and my SBW PVT, and name this the same thing but with an extra number at the end. So SBW PVT fire starts 2. Click OK. So my files have extracted, and here they are. So you can see that a new column has been added here for raster value. Now that's your number for your potential vegetation type, and to make things a little easier, we're going to use the same procedure that we had used previously to join the PVT number to the name. So we're going to close out of this and right click on our fire starts and do a join with the raster value and the PVT code. Click OK. And now in our table we have the names of those PVTs next to the PVT code and raster value, so we can continue to do our summarizing that way with those names associated there. So we're going to use the same procedure that we used in step 5 to summarize the information presented here. So right-clicking and clicking Summarize, and again, we're not going to be needing to select any specific calculations. We're just looking for a summary of the whole thing. And so we'll click OK. And in our summary table 2, and you could rename that, might be a good idea to rename those tables so that they mean something more to you. Open this up and we can see the PVT name and the count, meaning the number of fires in each of those PVTs. So with that information you can do some analysis. Excel might be a great tool to do this, where you would bring this information into Excel after writing it down in your table and then calculate your percentage of fires that started in each PVT, and then you can answer the questions about which of the PVTs had the most fire starts in them. Moving on to the next section, we will be doing polygon on grid overlays, and we'll be using some different tools in the Spatial Analyst tool pack, specifically the zonal statistics, tabulating area and combine, and also using the raster calculator. Zonal statistics takes a defined area, whether it's defined by a polygon or by the area for the zone grid, and it calculates statistics for that area, things like minimum, maximum, mean, range, and this is for continuous data such as elevations. We'll also be using tabulate area, which cross-tabulates 2 grids or polygon layers within a grid, and combine, which also cross-tabulates 2 grids and the outputs can be shown spatially. So the question that we're going to be working on right now is number 8. What is the min, max, and average elevation in the Whitecap Creek and Moose Creek watersheds? So we'll start out by opening our toolbox. And under Spatial Analyst Tools, we will select Zonal, and then Zonal Statistics as Table. Our input zone data is going to be our watershed layer, so HUC 5. Zone field is going to be first sub. Oops. First sub here, which is the name of the watershed, and the value raster is going to be the elevation layer. Our output table can be named whatever we want to name it. For now, let's name this SBW ELE zonal. And we will click OK. Now we'll go to our table of contents. It looks like we might be processing here. Let's check with our geoprocessing. Yeah, waiting on the zonal statistics to complete. Now that our zonal statistics have been completed, we can open up that table. Here they are. So this table, we'll open that up. And it looks like we have the name of the watershed, and we have some statistics for each of these watersheds on the min elevation, max elevation, range, mean, on all those things for that elevation grid. So in order to find the two watersheds that are in question, you can sort this by alphabetical, and then you can easily find the two watersheds that you're being asked about for your question and fill in the appropriate information. Moving on to question 9, which is, how would you calculate the percent of each PVT within the Moose Creek watershed? So again, under Spatial Analyst Tools and Zonal, we'll be doing Tabulate Area. This creates a cross-tabulation between two grids, or a grid and a polygon layer. We will cross-tabulate the PVT grid with the HUC5, or polygon layer of watersheds. First we will select HUC5, and then we will use the HUC5 zone field, and our input raster or feature class is going to be the PVT, and the class field can stay as value. This is a decent name for this. I'll just keep that the same for now, and click OK. So my tabulate area is completed, and I have a table down here. And so I'm going to open up my table. Next, we're going to answer the question number 9 about how you would calculate the percent of each PVT within the Moose Creek watershed. To do this, we're going to be using the tabulate area function in the zonal tools. So again, in Spatial Analyst, under zonal, tabulate area, our input raster or feature zone data is going to be our HUC5 layer, and our zone field is going to be first sub. Both HUC5 and first sub are unique identifiers of each watershed, but the first sub is the actual name of that watershed, which is a little bit more useful to us. Our input raster or feature class data is the SBW PVT. We'll keep it as value. This is an acceptable name for what we're doing, and so I'll keep that, and I'll press OK. My tabulate area has been complete, and I'll go here and open up this table and see what I have. So now I've got a table that contains the different watersheds and also the names of each of the different PVTs, or the numbers of those PVTs up at the top. And so the number in the table represents how many square meters in each PVT there are within each watershed. For example, there are 0 square meters of PVT value 2, which is Western Red Cedar, in the first watershed. You now have the data to be able to answer question 9. So in step 10, we're going to be doing grid to grid and using this information to answer question 10. So in GIS overlay analysis, it's a pretty useful tool for planning and stratifying sampling locations for vegetation and fuels, which is something we're doing a lot more of these days. In this example, we are planning a stratified sampling procedure by aspect and by potential vegetation type. So our question is, how much area of Douglas fir PVT is there on each aspect? Express the areas in hectares. So the first thing we need to do is reclassify our aspect layer into 5 different classes. So again, under Spatial Analyst Tools, we will go to Reclass, and then reclassify, and select our aspect grid. So currently the aspect grid is not classified, which means it has continuous values and it's not very useful as far as telling which aspect it might be. But we know that there are distinct aspects that behave certain ways, especially for fuel treatments. So this will be a useful thing to do. So we've got our aspect grid, and we'll keep that as values, and then we'll click classify. So as you can see, it's kind of randomly placed classifications right now and just an automatically generated number. We're going to change this to 6 classes. So again, it evenly distributes that right away. So the next step is to set our break values, and we will set those. This first one is going to be at 0. Second is at 45. Third is at 135, and these are all degrees around the compass dial, indicating which aspect we're talking about. 225, 315, and 360. We're good here, so we can click OK. So in the reclassification box, we're going to give flat values, this new value of 0, and then north is going to be a value of 1, and this one is going to be 2, and then 3, 4, and then back again to 1. There's 2 1s because the first one is half of north and the second is the other half of north. And now we can click OK. So we're now ready to combine the 2 data layers that we've been working with, these 2 grids, our aspect reclassified and our PVT. This will help us be able to identify the sampling locations by aspect and PVT for our fuel sampling. So unlike combining things with shape files or just adding different columns, we're going to be actually combining these 2 rasters and taking that information together, which is a pretty useful tool. So to do this, we'll need the raster calculator. So under Spatial Analyst Tools, under Map Algebra, we can click on Raster Calculator. And a good way to get started with this would be to take the equation from your lab and copy and paste that in just to get the spaces right. So as you can kind of get the feeling of, we're going to be giving ARC a command that says that we're going to be combining these 2 things. Now, if you have a different name for your reclassified aspect like I do, I'm going to delete that and then add my reclass aspect in for that. And I'm going to label this SBW PVT aspect and click OK. And I need to make sure that this is less than 13 characters, so I'll delete the SBW and put back in backslash. Let's try that. So our output grid, PVT aspect, is a grid that contains each unique combination of aspect class and PVT. Let's take a look at that. Now we are specifically looking at the Douglas fir PVT, and you can either look up which PVT number that is, or you could apply a quick join here and get those names associated with it. I'm going to join our SB PVT with the PVT table and click OK. And now our attribute table has those PVT names in it, and we can sort ascending. So now we can see our Douglas fir PVTs here, and then we can look at the aspect for each of those, and we can look at the count of pixels for each of those aspects, and we can fill that information in, knowing then how to calculate our area per pixel that we calculated earlier in the lesson. So continue on with that, fill in that table, and you should be all good to go now to answer the lab questions. Remember to save this ArcMap project. You may find it useful to go back in the future and review this information.